Let's talk about the effect of sodium hydroxide solution on different cations, or simply ions. And the cations we want to study include magnesium ion, barium ion, zinc ion, aluminium ion, lead 2 ion, copper 2 ion, iron 2, and iron 3. Let us start by looking at addition of sodium hydroxide solution on magnesium ion. Observation. And a few drops a white precipitate is formed. When you add few drops of sodium hydroxide solution on a solution containing magnesium ion, we are forming a white precipitate. The observation is simply white precipitate. And this white precipitate is due to formation of magnesium hydroxide. Now, the magnesium ion reacts with the hydroxyl ion from sodium hydroxide to form magnesium hydroxide. So that is solid. In excess of sodium hydroxide, the precipitate remains insoluble. Now, when we add excess sodium hydroxide solution, the white precipitate remains insoluble. So, we'll still have insoluble magnesium hydroxide. So this is still magnesium hydroxide. The second one, let us look at addition on barium ion solution, maybe barium chloride, which is a solution containing barium ion. So we'll have few drops, or simply dropwise, and then excess. So that is dropwise, and then we'll have excess. So dropwise, the observation is white precipitate is observed. Or simply, white precipitate is formed. In excess, the white precipitate remains insoluble. Let us now see the cases of our white precipitate under limited supply and excess. So that is when you do the dropwise white precipitate, then excess of sodium hydroxide solution, we still have formation of a white precipitate which remains insoluble. So the precipitate remains insoluble. Now the equation for the reaction is as follows. It is barium ion reacting with hydroxyl ion to form barium hydroxide, which is solid, and this is the white precipitate which remains insoluble. Now those are our two. That should be two for us to have the equation well balanced. There has to be 2 as a coefficient of hydroxyl, and that is what we have said is a white precipitate formed. So to balance this equation as well, we must have 2 there. Number 3, let's have addition of sodium hydroxide solution on copper 2 ion. Maybe copper 2 nitrate having copper 2 ion. So that will be few drops or dropwise of sodium hydroxide. So this side will have dropwise, and then we have excess. So dropwise observation, we have blue precipitate is formed. Excess blue precipitate remains insoluble. So that is due to formation of copper 2 hydroxide, where we have said we'll have underdropwise blue precipitate, and even in excess the blue precipitate remains insoluble. So that is the blue precipitate with copper, and under excess, that is when you add excess sodium hydroxide solution, we will still have the blue precipitate being insoluble. The equation for this reaction is as follows. We have copper 2 ion reacting with the hydroxyl ion from the sodium hydroxide to form copper 2 hydroxide, which is in solid state. The next one is ion 2, that is number 4. Ion 2 ion, dropwise, then we'll have excess. So dropwise of sodium hydroxide solution, we are forming green precipitate. Green precipitate is formed. That is observation, dropwise, excess, green precipitate remain insoluble. So it gives a green precipitate that does not dissolve in excess, meaning it is due to formation of ion 2 hydroxide that remain the same even in excess. So that is limited supply, where we are able to see there is the green precipitate with ion 2, and in excess the green precipitate remain insoluble. We now have excess of that. Our green precipitate is there insoluble, and this is due to the reaction between ion 2 ion with the hydroxyl ion from sodium hydroxide solution to form ion 2 hydroxide, which is in solid state. Our next one is ion 3, that is number 5. iron, 3 iron. So we have dropwise and excess. Under dropwise, there is formation of brown precipitate. So brown precipitate is formed. Excess brown precipitate remain insoluble. So this brown precipitate is due to formation of iron 3 hydroxide, which on addition of more drops of sodium hydroxide solution does not dissolve, but instead remain insoluble as shown in this given test tube. So this is when it is few drops, and that is excess. These few drops, even if you leave it for long, it will still remain insoluble. The reaction there is that iron iron reacts with the hydroxyl ion to form iron 3 hydroxide, which is the brown precipitate. The next one is zinc ion. Zinc ion in dropwise will give a white precipitate. So a white precipitate is formed. In excess, white precipitate dissolves to form colorless solution. So that is due to formation of a complex ion. Let's look at case of few drops, where we have said that will give a white precipitate, but in an excess, the white precipitate dissolves to form a colorless solution. So in few drops, that is the white precipitate, you can have another different test tube, but same white precipitate, Then in excess, the white precipitate dissolves to form a colorless solution. And we have said the colorless solution is simply due to formation of a complex. So two reactions will take place here. The first one is for the white precipitate, where we'll have zinc ion reacting with hydroxyl ion to form zinc hydroxide. And this is the white precipitate. Then in the colorless solution, the white precipitate formed reacts with more hydroxyl ion from excess sodium hydroxide to form a colorless solution. So that is the complex ion formed that is now colorless. Zinc tetrahydroxide ion, as you can see in the equation. Number 7 is what we call aluminium ion. Dropwise, then we have excess. Aluminium dropwise, there is formation of a white precipitate as the observation. White precipitate is formed. In excess, the white precipitate dissolve to form a colorless solution. Let us have a check on the white precipitate that is formed, and that is due to formation of aluminium hydroxide. And this aluminium hydroxide, on excess addition of hydroxyl ion, it will give a colorless solution, and that is due to formation of a complex. So that is the colorless solution. So the reactions which take place here include the first one, aluminium ion, maybe from aluminium nitrate, reacting with the hydroxyl ion from sodium hydroxide to give aluminium hydroxide, which is the solid substance. Then this aluminium hydroxide will react with the extra hydroxyl ion to form a complex. And this is the complex that we get from that given reaction. So this is a colorless solution. Finally, the last one, number 8, we have lead to iron under dropwise and excess. Observation under dropwise: a white precipitate is observed or formed. Excess: the white precipitate dissolve to form a colorless solution. In the dropwise, we have said we have a white precipitate of lead 2 hydroxide. Then in excess, the precipitate dissolves to form a colorless solution. So that is white precipitate, and this is our white precipitate of lead 2 hydroxide. Then in excess, it will form a complex, and that is why we are getting colorless solution. So this is the complex ion formed. So the reactions as follows: lead ion reacts with hydroxyl ion to form lead 2 hydroxide, which is the white precipitate. Then this white precipitate reacts with excess hydroxyl ion to form a complex ion, and that is what is responsible for the colorless solution. So this is colorless. So it is clear that the amphoteric oxides, aluminium, or simply amphoteric hydroxides, that is aluminium, zinc, and lead, are able to give what we call the colorless solution with excess sodium hydroxide. Now, I want us to recall the observations that we talked about when we were learning the addition of ammonia solution. We said that is only zinc ion and copper 2 ion that are able to form complexes, and for that reason they give solutions in excess addition of ammonia solution. In this case today, we have realized that aluminium ion zinc ion and lead ion with excess sodium hydroxide, they give colorless solutions. They simply give solution due to formation of complexes. So it is this complex ion formation that enables a solution to be realized on excess addition of either sodium hydroxide solution or ammonia solution. Now, from this chemistry, we can therefore conclude that only zinc ion, or simply only zinc hydroxide, is able to dissolve in excess. Only zinc hydroxide dissolve in both excess ammonia solution and sodium hydroxide solution. Very important. That is why when you do for ammonia, you get zinc ion, few drops, it forms white precipitate, then excess gives colorless solution. And the same story happens when we now use a sodium hydroxide solution. In complex ions, the ammonia molecule and the hydroxyl group form a dative bond with the metal ions. And these complex ions are important in industry and also in biology. Like chlorophyll and hemoglobin are already complex ions. Like if you check the hemoglobin, it is a complex ion, and it helps in the blood oxygen transportation in the body in the form of oxyhemoglobin. That is all about the effect of sodium hydroxide solution on different metal ions.